Hello! For this project, I'm analyzing average commute times across the United States using real data from the 2022 American Community Survey, which is run by the U.S. Census Bureau. I chose this dataset because commuting is something that most people experience every day, but we rarely stop to think about how much it differs depending on where you live. Some people drive a few minutes to work, while others spend close to an hour commuting each way. The essential question for this project asks how we can use statistics to describe, compare, and interpret data to reveal meaningful patterns. Through this analysis, I want to see how commute times vary across states and what those differences say about daily life, transportation, and urban design in the United States. So this dataset measures the average commute time in minutes for workers in all 50 US states plus Washington, D.C. Because commute time is measured numerically, it's a quantitative variable, which makes it perfect for statistical analysis. The data comes from the American Community Survey, which I mentioned earlier, which collects responses from millions of households, making the data reliable and representative of real working adults. So since there are 50 US states and Washington, D.C., there are 51 total data points, which gives us enough data to find patterns and trends. I'm especially interested in seeing whether most states are similar or if there are a few states that really stand out when it comes to commute time. So to understand what a typical commute looks like, I calculated the mean, median, and mode. The mean, or the average, commute time across all states is about 26 minutes. This gives us a general idea of how long people spend going to work. The median commute time is about 25 minutes, so about the same, meaning half of the states are below this value and half are above it. The median is especially useful here because it isn't strongly affected by states with unusually long commute times. Now, there isn't a meaningful mode since no two states share the exact same average commute time. Because the mean and median are very close, this tells us that most states cluster around the same general commute length without an extreme skew. So next, I looked at how spread out the commute times are. The range is about 15 minutes from the shortest average commute of 18 minutes to the longest at 33 minutes. This shows that commute times vary depending on location. So the standard deviation is about 3.6 minutes, which tells us that most states' commute times are generally within about 4 minutes of the average. Since the data is fairly balanced, we can apply the empirical rule. So about 68% of states fall within one standard deviation of the mean, which is about 22 to 30 minutes. About 95% of states fall within two standard deviations from about 19 to 33 minutes. When we look at the histogram, this pattern makes sense. Most states cluster near the center, with only a few near the extremes. To make patterns easier to see, I grouped the data into three categories: short commutes from 18 to 22 minutes, medium commutes from 23 to 27 minutes, and long commutes from about 28 to 33 minutes. Most states fall into the median commute group, which supports the idea that typical commute in the US is around 25 minutes. Grouping the data helps simplify the story and makes it easier to compare groups rather than focusing on individual states. This is especially useful in real-world situations like transportation, planning, or policy decisions. So then I looked at the measures of position, which help explain where specific values fall compared to the rest of the data. First, I calculated the quartiles. The first quartile, or Q1, is about 22 minutes, and the third quartile, Q3, is about 28 minutes. This helps me find the interquartile range, which shows how spread out the middle half of the data is. To find the IQR, which is the interquartile range, I subtract Q1 from Q3. So 28 minus 22 gives me an IQR of 6 minutes. This means the middle 50% of states have average commute times within a pretty small range, which tells me commute times are fairly consistent for most states. Next, I check for outliers using the 1.5 times IQR rule. When I multiply 6 by 1.5, I get 9. Adding and subtracting that from the quartile range gives me the fences at 13 minutes on the low end and 37 minutes on the high end. Since no state falls outside of those values, there aren't any official outliers, but some states still stand out more than others. To look at that more closely, I calculated a z-score for New York, which has an average commute time of 33 minutes. Using formula z equals x minus the mean divided by the standard deviation, that's a lot of words, I get a z-score of about 1.94. That tells me that New York's commute time is almost 2 standard deviations above the mean, which makes it unusually high compared to most states. Even though it's not a strict outlier, it clearly stands out, which makes sense considering traffic, population density, and public transportation in New York. Overall, measures of position help explain not just what's typical, but which values are noticeably different and worth paying attention to. So now we have a box plot. So the 5 numbers summary gives a clear snapshot of the data. The minimum is 18 minutes, the first quartile is about 22 minutes, the median is 25 minutes, which is Q2, and the third quartile is about 28 minutes, and the maximum is 33 minutes. The horizontal box plot shows that most states are grouped fairly close together, but the higher values stretch further than the lower ones. This shows a slight right skew. The box plot makes it easier to see spread and outliers than just looking at a list of numbers. When we combine measures of center, spread, and position, a clear pattern appears. Most states have similar commute times, but states with larger cities tend to have longer commutes. This information could be useful for urban planners, employers, and policymakers when thinking about transportation systems, remote work, or quality of life. Statistics help turn everyday experiences into meaningful insights that can support real-life decisions. This project helped me understand that averages alone don't tell the full story. Measures of dispersion and position added important context and helped explain why some states have very different from others. The most useful tools for me were the box plot and group data because they clearly showed patterns and outliers. And the normal plot, the normal graph was also pretty good, just like to visualize all the states. But the box plot and group data were pretty good. And these statistical skills are useful beyond this class, whether interpreting data in the news, making personal decisions, or doing future academic research. Thank you for listening.